So molar mass is the sum of the atomic masses of all the atoms in a formula, written in units of grams. And in this class, molar masses will include units of measurement and the species, the chemical species, and will always be written in the form of an equality statement. Okay? So, let's look at a formula for a very simple molecule or compound, O2. Remember, molar mass is the sum of all the atomic masses. Where do you find atomic masses? Oh, good. That was a great chorus there. Wow. Okay. So the atomic mass for oxygen is 15.9994. And if it's the sum, what does that mean I have to do? Add of all the atomic masses of all the atoms in a formula. How many atoms do I have in this formula? So I have to add it twice. Okay. Now there's no empty slots on the right, so there's no reason to round off this answer. Okay. But we're not finished because it tells you up here what you have to do in this class. Well, the first thing we got to do is have units of grams. We have to have the species. What's the species here? Oxygen or O2.
Is that
9988. 31 point, huh? Oh, 15.9994. 15.9994. But you should have out your periodic table looking it up for yourself. Okay? And we also have to write it in, so I have to have this equal to something else, and by definition, the sum of all the atomic masses of all the atoms in the formula is equal to, you did this in your Mole Day project, equal to, fill in the blank, somebody. Well, that would be true. It would be 6.02 times 10 to the 23rd particles, but that means it's equal to 1 mole of O2. Every time you calculate the molar mass, it will be equal to 1 mole of that species. 1 mole. 1. Okay? Not 3, not 5. I don't care what the equation is. I don't care what anything else is. Molar mass is equal to 1. Okay, that's the definition. Or one of the 3 things in your mole ratio or your Mole Day project you had to tell me it was equal to. The sum of all the atomic masses of all the atoms in the formula. Okay, now let's do the molar mass calculation for this. Okay? Do the molar mass calculation for that.
What is that, C5?
C5H12. Boy, you guys are just so good. Absolutely nobody's complaining. Joe says he's going to complain, though. Okay.
What?
Joe said, raised his hand. He says he's going to complain. What are you going to complain about, Joe?
Why is this a chicken coop half forward?
Oh, we don't care about that. We care about this right here. Molar mass for this, okay? Come on.
Do we have to add it? Can we just multiply it by 5?
I don't have a
Ooh, that was what I was looking for right there. Do you really want to add hydrogen's molar mass, atomic mass 12 times?
No.
What's an easier way to do that? Huh? Multiply. All right, so here is the actual format that I require in this class. Okay? Whenever you calculate molar mass, I just want somebody to speak up. It's all right. Because I get you engaged when you speak up and say, is there an easy way to do this, right? Good for you. Pat yourself on the back. Okay? What?
Wow.
This is the regular way I'm about to show you right now. I want you to write down the symbols for the elements. Then I want you to write their atomic masses next to those symbols. I'm sorry, that should be H. You're right. I'm sorry. I'm thinking CO2 or something. I don't have a clue. All right, it should be H here. I'll come in and write an H after this dries, okay? And what's the atomic mass for H, for hydrogen? 1.00794. Okay. How many carbons do I have?
5.
Multiply by 5. How many hydrogens do I have? 12. And then when I do that, let's see. I got this will become 60.0535, and this becomes 12.09528. And notice I've lined up all my digits really, really neatly. Neatness counts here with significant digits because I can clearly see I've got an empty slot. That's going to make this 8 down here whenever I do all the addition is going to be insignificant. We're going to underline it. Okay? So we add those together. We get 72.1487. Okay? So we're going to round off that last digit. We get 72.1488 grams C5H12 equals 1 mole C5H12. And that's the molar mass of pentane. Okay?
This doesn't get harder, does it?
For molar mass?
Yeah.
Not really.
Yep.
But now we're going to use this to do other things. Okay. Do you have a question, Jamila? Did you have a question? Okay. All right, pay attention here. Pay attention here. This is important. This is really important. When you have one thing equal to another, one thing equal to another that has a name, and we're going to call it this every time, an equality statement. An equality statement. It's one thing equal to another. There are lots and lots and lots of equality statements. Okay? But here's why it's important to understand what the term means. For this class, equality statements are required. Equality statements are required before you build a conversion unit. Okay? And in this unit of chemistry, stoichiometry, we're going to be building lots and lots and lots of conversion units. Okay? This is all about converting. Stoichiometry is all about converting. Okay? The system we're using for this stoichiometry is called dimensional analysis, which I've been training you to use since the very first unit in here. Okay? So hopefully this is going to become smooth, okay, like water on ice. Alright? It's going to be slick. Okay? Got it? Okay. Now, let's look at the word unit for a minute. What in the world does that mean?
1.
It does mean 1, and when we talk about a conversion unit, it means 1. Okay? Now, a unit means a single, something with a single purpose. Okay? It kind of implies 1. And a conversion unit in math and science, is something that actually equals 1, but is used to convert from one unit of measurement to another without changing the value of the starting stuff. Okay? Here, building conversion units, once you have an equality statement, is super easy. Okay? If I put this amount right here, 72.0148 grams of pentane, in a fraction, I put this on the top in the numerator, and I put this in the bottom in the denominator, what does that fraction equal? 1. Anytime you put two things that are equal in a fraction on top and bottom, it equals 1, right?
Yes.
What's 2 over 2 equal? 1. What's a dozen over 12 equal?
1.
Okay? Got that? What's 100 pennies over $1 equal? 1. Anytime you put two things that are equal, top, bottom, numerator, denominator, and the fraction equals 1. Okay? Now, if you multiply by 1, you get the same thing you started with, right?
Yes.
So what we're changing is the way it's measured, not changing the actual amount. Does that make sense? All right. Now, molar ratios change the amount sometimes, but all the other conversions we're going to use in here don't change the amount. They only change, or at least in this unit, they just change how we're measuring it. Now, there are two conversion units you can write from this equality statement. The first one has this on the top, that on the bottom. And the second one would be this on the top, that on the bottom. Please write both both conversion units for this equality statement and label it.
So an equality statement is just the opposite of what you get.
No, this is the equality statement.
Yeah.
The conversion unit is built from this. It's not the opposite. I wouldn't call it the opposite anyway. Okay? You can build two conversion units from this equality statement. I want you to write both of them so you know what it is. And label it right underneath it. These are both equality statements. Okay? So you have in your notes what an these are both conversion units. I want you to write underneath it and draw arrows to it so you have in your notes what a conversion unit is and why it's and how you built it on top of the construction of, in this case, this equality statement. Okay?
Can you put it equal to?
You can say equal to 1, but you don't have to. I just want you to write the fraction and put a label on it that says this is a conversion unit built on this equality statement. Okay?
And you said put it over the 1 mole.
No. Yeah, this whole thing, this whole side here on top of the fraction, over this whole side here on the bottom of the fraction.
Okay.
And the other one is this whole side here on the top over this whole side here on the bottom. Okay? Two conversion units. And label them clearly in your notes. This is a conversion unit. Okay?